Okay, thank you very much. Thanks, Chair, for having me in this session. Today, I'm going to present on behalf of my new project. It's about the project fracture behavior of natural fiber reinforced epoxy composite using a small bunch test. Presenting on behalf of Professor Sabrina Vantadori, Prof. Hossam, and Prof. Amr Abd-Elhady. It's about the project that we started to work on it, and this is the most of the pre-experiment result that we got in this one. My presentation will be about the objective of this work, some of the material that we have been using, about the palm fiber that's here in Saudi Arabia, the testing that we have done up to date, some of the results that we can obtain from this study. Finally, some microscopic analysis, still we are doing the scanning electron microscope, and some of the conclusion that can be drawn from this study. So for the objective, we try to combine the natural fiber with the epoxy or reinforce the epoxy composite to enhance some of the mechanical properties, especially some of the toughness or stiffness for the material. Also, we try to analyze some of the results using a different fiber compared to the glass fiber, compared with the natural fiber or palm fiber. And finally, we compare the result of the natural fiber and glass fiber and compare with the epoxy without adding any kind of reinforcement. Uh, as we all know, there are commonly used natural fiber in the composite fabrication, starting from for what we have for the animal, and we get some for the from the plant, and we can extract some from the mineral. For our study, we go with the plant natural fiber, especially for the palm tree. Back home here in the southern region of Saudi Arabia, it's a very rich country of the dates of palm tree, and this is a real one that we get the fiber from. It's near to my house, and we get this tree. I mean, this fiber which is very close to the branches, and they use it to after they get the date, they throw it away or they just use it as a seed. So we took out some of this fiber and we try to use it as a natural fiber to reinforce different kind of epoxy, to use it for industrial application, and we hopefully at the end we get some good result at the end of this road. So for the testing that we used a small punch test with the standard for the sample. It's around 6 millimeter in height and 17 millimeter in the width. For the Brazilian test or the diametral test, the sample will be around 40 millimeter long and 6 millimeter in diameter. For the fabrication of the mold, we got some difficulty to have the mold based on the small bunch test of the Brazilian. We try different way. We use the 3D printing machine to do the sample for the small bunch test. Also, we got some easy used, or I mean manufacturer used silicon mold. Also, we try to manufacture our own mold for such kind of samples. For the Brazilian, we have it; it's already used. We just put the sample inside and cast it inside this one, and we cut it after it's dry and cure to have it for the test. For the fabrication, using the 3D printing, we do the blueprint, and at the end we get the final shape that we are trying to do. We get some difficulty, some of the sample stuck due to the high roughness for the layers of the 3D printing. So we do some kind of smoothing the surface, and at the end we get some good result or some good sample that can be used for the small punch test. In order to have a very good conversion for our study, different kind, we try to get the natural fiber which is from the palm tree, compare it with the glass fiber, and compare it with the pure epoxy without adding any kind of fiber. For the natural fiber, we use a different weight. We start with the low, medium, and high as compared to the weight of the sample. It's a weight percentage. And for the glass fiber, we just only used one compared to the medium, and we see how is the result is going to be after doing the small bunch test and with the Brazilian and do some microscopic analysis for the fracture surface. For the manufacturing, for the natural fiber, as we said, we dry the fiber and we do some cleaning and use it in ethanol bath, and we cut it to a certain type, certain length. Then we use the sonicator to mix the resin and the hardener with the epoxy until we get it to the final shape, even for the small bunch test or for the Brazilian. For the glass fiber, we did the same way, which is reused. We just cut it to the certain length that we need. We do the cutting. Can you hear me? There's a sound.
Yes, yes,
Hello?
please. The other people have to close the microphone.
Okay, okay, good, no problem. So this is for the glass fiber. We did it as what we done here, but it's only for 1%. For the testing, as I said before, this is the picture that we have for the small bunch test, and this is for the Brazilian that we used in our lab. Just to be more details about the small bunch test, this is the picture that we manufactured in our lab. It has upper and lower die. We apply the load in this area, sorry, in this one, and the sample will be put as what we can see here. And we apply the load until we fracture the sample. Then we have it for the final. I mean, to record the loading and the stress strain. Sorry, the stress, and we do the microscopic analysis after the fracture. More details about the small bunch test. This is the load displacement curve. For the load displacement curve, just there are 4 regions. For the standard, we have the elastic region, which is very small in the beginning. Since we have epoxy, it's a very more brittle. It will be very small region in this one. This is the transition between elastic and plastic. We go to the stretching here until we get the fracture. So we try to see how is the behavior of the sample during the small bunch test. Even when we have adding some fiber, try to increase some of the, I'm not going to say ductility, but more stiffer for the material. Here we are trying to show the result for the low fiber. As we can see, this is the load displacement curve. We can see it is following the same, very same trend for the small bunch test. The good thing that we can notice here, there are more resistance at the peak before the fractures. That sample start to get fractured, then it gives more resistance due to the introducing the fiber, and they start to get fracture at the end. The average is around 140 load Newton, which is, it is like a very small sample. It is more logic for this one. For the medium, when we add more fiber, we notice that it is following the same trend, except there are at the peak, there is no more of the resistance. The sample start to fracture, which is showing us that like we start to create internal cracks. The fibers act as internal crack as we add more. So there is an optimum amount that we should study and see what is the optimum. Even for the high one, I mean, adding more fiber, we start to get the high peak. It's getting very good, but at the end, start to fracture. There is no more resistance at the peak when it start to fracture compared to this one. For the glass fiber, we did some testing, and we can see that for glass fiber it has a very good resistance at the peak. However, for the natural fiber, it's giving like comparing to this one around 15 to 20% increasement in the load when we compare it to the glass fiber. Here's doing some for the averaging for the small bunch test to show more how it looks like. For the high fiber, for the natural fiber, it's getting good as we add. I mean, reducing the amount of fiber that start to reduce the load. For the Brazilian, since we doing the diametral testing and we apply the load horizontally, we can tell like the low fiber giving more results. Is not good. It's not as it is what we have in the small bunch test. Because we apply the load at the horizontal way, so more fiber with the contact surface, it will give us like more crack that can be generated at the internal of the sample. Finally, we calculated the area under the curve for all the samples, especially for the small bunch test, and we can tell like that the presenting in general, the presenting of the natural fiber, giving some good result comparing to without. I mean, this is not a glass fiber. This is just only the epoxy without adding any fiber, and that's a very good like start that we can start from in this one. Finally, some of the microscopic analysis that we try to see here. In this one, this is a single natural fiber that's surrounded by epoxy for the small bunch test after the fracture. Here we are showing some of the epoxy residue that is clinging to the natural fiber, and this is like the cross section for this one, and we need to do more of the SCM for this one. Here we are trying to show some. This is the white one. This is the glass fiber surrounded by epoxy after fracture. This one we try to show like for the orange one. This is a single natural fiber or palm tree fiber at the epoxy during the fracture, but it is internal of it is entering the it is inside the sample. Here just only epoxy to see the fracture, which is brittle, and we can tell from this picture how it looks like. We like this picture, so we added this about two natural fiber that is bonded together with the epoxy. Finally, this is a broken glass fiber in the middle. It's like a bundle, and there's a fracture here that we get it from the small bunch test after testing. And finally, this is a natural fiber bonding between two pieces, or like anchoring inside the epoxy after testing. The conclusion that we can get from this one, that we successfully manufactured the epoxy composite reinforced with natural fiber, which is the good start for our study in the future. Also, in general, introducing the fiber and epoxy composite help to improve the overall some of the mechanical properties. The small bunch test results show that high percentage of the natural fiber help to improve the maximum load before fracture. Brazilian test results showed that low natural fiber percentage have more maximum load compared to other sample. And finally, the microscopic images showed different fracture trend after testing. And in the meantime, we are doing some of the finite element simulation for such kind of testing, and we do some notch sample and doing some more of the SCM. That's all, and thank you very much.